Okay, so this is kind of a continuation of my last video. I showed you some parts I was making. This is a worm gear and worm drive for it. So I was going to talk about how to lay it out and how to get everything made for it. So obvious, here's the worm. I used on this one, I used 5mm pitch. There's the gear, 60 tooth on the gear, same 5mm pitch of course. So layout for the worm itself is pretty straightforward, just an end view, so you're looking at the thing like so. And you got your root diameter, your tip diameter, and in the engineering drawing they're going to give you a pitch diameter for the gear itself. You don't really need that on here. You're basically worried about the tip and the root. So you lay out your root diameter, your tip diameter, center, and you're going to have another part of the layout that you're going to need later, and we'll get into that. So this green layout here is the gear itself, and that'll help you decide how to make the pattern. And then of course you got the top view, which will show not all, but your angles between the teeth, and it'll show your pitch diameter, your root, and tip diameter. This is what we called them in the pattern shop. I know there's names, engineering names for them. We never really use that. We just made it simple on ourselves. So to get to the pattern, you lay out this view. So for the green area, you know you're going to have a core print coming up this way and out, and this way and out, and from there you're going to have to decide cope and drag. So then you'll have the draft going this way on it. That would be your pattern. So your pattern's going to end up looking something like this. So this is your side view. So here's your draft here. Looking at the top view, you got your cutouts here, your rim here, and in the core box itself is where your teeth are going to be. So the layout's pretty straightforward. For the pattern itself, you have cope and drag core prints for the bore, and this one I made the cope core print loose, which you can do, or you can make it fixed and put a hole in the center of your follow board if you wish to do it that way. The follow board sits, get in there, like so. You know, on this one I put the gear or the web at the center just because it was easier to print than that. I had to do that in two pieces. Yeah, I didn't want to have to use supports on this to make this one, so I did it in halves. So that's gets you to the pattern for the worm gear itself. And after you get that done, you also need to make the gear, or the drive, I'm sorry. And to get to a drive, you got to make, and to cut the teeth for those, you got to make a tool. Tool is pretty straightforward as well. Basically a piece of round stock. It can be turned or sawed and sanded. You support it on a bandsaw, and you set the bandsaw to the angle of your teeth here. So you'll have this set at whatever the angle is. I think you can see that, and if you can't, it's there. Let's see, how's that? There you can kind of see the angle, okay? And you'll do a layout of your teeth. So on one side, you're going to be cutting, this would be for the gear itself, because this one would go here. And if you can see it, I don't know if you can, I'll see how close I can get it, but it's tapered where the top of the tooth here is skinnier than the bottom. So that matches these angles here. And the other side, for the actual worm itself, it's just the opposite. But both of them use the same, they'll use the same radius, this one right here, for this tool. Then you'll cut them both out. You set your tool at an angle, you cut each side out, and then these would be as cast teeth, and you use a small block sander to smooth up the saw marks. So to get to that and what they'll look like as a pattern in a core box, I made these a little bit bigger. So here's what the pattern to the drive would look like. It's just a split pattern. Ram up one side, add the cope. It's pinned together, and the pins are located in such that if you reverse it, they don't line up. That makes it real easy for you to make sure you don't mess up the whole thing. So always offset your pins so you can tell if the thing is lined up properly. So that would be the pattern. Obviously I made this pattern pattern model twice the size of this one, so it's easier to see. On the ends here, this would be radial draft, so you have the same angle this way at the parting line as you would up here. And that gives you a nice radial draft, clean looking part. And that's ready to go. And to get to the point of actually cutting your teeth, you need to know the exact circumference of this root diameter here. And you'll do a layout something like this. Okay, so this is your pitch here. I don't know, it'll probably be upside down for you, but this is your pitch. Then you'll lay out on a cylinder you make, and you'll cut sections of teeth out of that cylinder. You basically cut one side, flip it end for end, cut the other side, and you're good to go. You'll lay out your root width on that pitch diameter and your tip on, so you have enough for all of them. Of course, on your pattern for the worm, you're going to have to make enough to go all the way around the thing the number of times that you need to go around it. Not to drive the gear itself, you need to make a core box. So this would be your core box. It's basically a segment box. You'll put a stop off in it. It comes apart here, so it's pinned. You'll put a stop off for where you want to split it. I made this one a little long for demonstration. So for this 60 tooth gear here, you can put 6 teeth in here. This first tooth is split in half. So since that's a half tooth, you count 5 here. And this one here would be split in half with a stop off. That would go in here. And that'll give you 6 teeth, so you need, in this case, 10 cores to go all the way around the part. When you do your core box and you're figuring out how many teeth you can incorporate in the core box, the one thing you need to make sure of is you have drafts. So this dimension here needs to be wider than this dimension up here. And that'll make sure it'll draw out of the sand nice and easy. And that's basically all it is. This is about as much direction as I got when I served my apprenticeship. Of course, they kept an eye on me to make sure I did it right, and apparently it was, because we never got the part back. So that's just a quick little video on how you'd lay out the worm drive. You need to know this number, the root diameter, number of teeth, and to get your gear. And it's pretty straightforward after that. The thing about a worm drive is when you get it set up, the drive itself is the only thing that'll drive the gear. You can't drive the worm with the gear because of the way it's set up. This won't cause the gear to or the drive to rotate. So the drive and the gear only rotates by rotating the drive. However, the worm drive can drive the gear both directions. So that's about it. And to finish this thing off, I had to make something to drive it with, or put it on to drive. Here's all the pieces I made for it. Let's see. So to put the drive in here, I need a place to hold it. So I've got a bushing, thrust washer, my drive goes on there, that goes there, goes there. This then sits in here. Got a bearing cap, goes there. Yeah, let's see if I can do this right. And bearing cap goes there and there. Screw those in place. Get this out of the way. And gear would go on here. Like so, I got the gear and the table, and that goes in here like so. That rotates. Let's see, do I even want to put this thing together? Let's put it together. And if you did it all right, as you rotate this, that turns. So 60 rotations of the worm will rotate the gear one time. And it'll go both directions. However, you cannot drive the worm with the gear. So that's basically what I did about the 4th year of my apprenticeship. It was, if I remember right, it was for a sugar mill in Hawaii for the cane processing. That was a long time ago, and it all seemed to work because it never came back. The question was about that part. How I'd go about producing a pattern for it rather than trying to build it machine the part itself. So looking at it, there are several ways you could mold this thing. This part here, one of the ways I came up with that I didn't really like was the parting line would be down the center of this area, and this area would have to be cored. Looking at the part, all these holes are going to be filled in. There would be machining on each one of the bosses. On this side only, on this one. Let's see, this should be right side up this way. Like I said, this is half scale. This is 75 millimeters across here. That's 150. But you'd talk over with the engineer, find out where the areas of machining are because it's not marked on this. So it'd be The end of the ears here. You'd fill in all the holes, and there would be machining each side of the boss, and on this one just one side of the boss, and these holes would of course be filled in. So after you get that all taken care of, then you discuss it with the foundry. You get your layout done, and I'd tell him my opinion, he'd tell me his opinion, and since I am also the foundry, my cope and drag were this way. This is the drag side, this is the cope side, this yellow area is my core box area. And in this area, let's see, depending on how I wanted to make it, basically this would be the edge of the core box here and here, like so. This is a little excessive out here. No real reason for it, so I reduce the size of it. The open face of the core box would be here on the parting line, so no face of the core that has to be struck off will touch the casting at all. It would be one core box. And splitting it that way, I could very easily put a riser here to fill this area in, make sure it's solid. This area over here is probably where I'd put the gate. So I got the gate there, and the runner would be in the cope or drag, depending on how I wanted to do it. Probably in the drag for the runner, in gates in the cope. And that makes everything pretty simple. I can get to everything I need to, and the job is pretty much done. It would simplify the pattern considerably in the fact that I just have a dump core box, no loose pieces. If I split it this way, like I was talking about, that would have to be a split core box, and the core box would be considerably bigger than this one. And same thing if I split it this way, I would still have to have a split box, and it would be quite a bit, let's see, this way, it would be quite a bit, pretty good size core box to get all this in there. So didn't like either one of those options. This one works better, and you can mold everything up. I'm not going to go through and actually make a model of the pattern core box itself like I did on the widget casting I did. It's basically just to show you why communication with the foundry is important, the communication with the engineer, the design company is important, and you would make a layout, which is also important, so you know exactly which way you want to work this thing. So those are my thoughts. This is a relatively short video, I hope, for both the worm drive and gear and this little bracket of whatever it's supposed to be for. So that's it. Let me know what you guys think, and if you got any questions, feel free to ask me. So you guys have a good one, and we'll talk to you later. Bye.